Now, before we get started, are there any questions on any of the assignments thus far?
I don't know if I know that right.
Number 7. So, you're good. I have one right here. Yes. Okay. Well, I'm going to make a circle. Number 7 is what we'll look at. So we have a circle. Now, we'll put this point here, which is close to the center. Line going through the center. Then we have a line here. And then, see here. Okay. And then a line like this here. And then that kind of extended out. Now, our lettering is A, B, C, J, K is up here. Down here is G, this is H, F, D, well, this is D, this is E, arrow, arrow. And number 7 is to name 2 chords. Well, by definition, a chord is any line segment that connects 2 points on the circle. So, 1 point on the circle would be A.
Yeah. That's the diameter.
D. Yeah. A chord. Yeah, because a chord is any segment that connects 2 points on the circle. A diameter is a chord that goes through the center. And the other one that we could have is DH.
Is AJ not one?
AJ would not be one because AJ would go from here to here.
Okay, my bad.
Yeah, so it is a segment, but it's not one that we would have any information to. Because that's 3, isn't it?
Yeah.
Yeah. Yeah. Or we could call it technically. Now, if they said name circle C, if they started off with this, then we'd want that. Any other questions on the homework? Are you ready for today? So I included the arcs there just in case we need it, but we did cover it last time, so we're going to move on past it. And this is the first thing we're going to talk about. If the measure of angle ABC is less than 180 degrees, then the points on angle or circle C that lie in the interior of ABC form a minor arc. So if the measure of the arc is less than 180, it is a minor arc. The points on circle C that do not lie on the minor arc AB form a major arc. So if it's greater than 180, it is major. Greater than 180, major. Less than 180 is minor. And exactly 180 would be a semicircle. 180 degrees is half a circle, so it would be a semicircle. Semi means half. So the measure of an arc, measuring arcs, the measure of a minor arc is the measure of its central angle. A central angle is an angle formed by 2 radii. So the measure of the central angle is the same as the measure of the arc. So the arc AB is 50 degrees because its central angle is 50 degrees. Now, we're not talking about the actual distance. We're not talking about the distance from A to B if we traveled from those 2 points. We're just talking about the degree measure. So we have this here. And whenever we use 2 letters, we're always going the shortest distance. So for this here, we would call it the measure of AB, and we put a little arc above it. For a major arc, if we're going a longer distance, we use 3, where the first letter is the starting point, the third letter is the ending point, and the middle letter is kind of telling us which one we're going through. So the measure of arc ADB says we're starting out at A, going through D, and ending at B. Now we know the entire circle is 360, and if I know this part here is 50, we can say, yes, we can subtract it. 360 minus 50 is 310. Questions on this here? Find the measure of each arc. So RS. So RS is going from R to S. So the measure of RS would be 110 degrees. So since the central angle is 110, it is 110. Now RTS. R T S. Well, it's everything except for 110. So we can say what? 360 degrees minus 110 degrees, 250 degrees. RST. So let's look at it. So it says we're starting at R, we're going through S, and ending at T. And they told us RT is the diameter, yes? So this would be 180. Because if an arc connects to the diameter, it's going to be half the circle. Questions on this here? We ready for the next one? We'll do this one here and then we'll move on because I don't think we need to do a whole lot with this. AD is 65. Same as the central angle, 65 degrees. DAB. B, A, B. Now they told us AB is the diameter, so from here to here, I can indeed say it is 180, yes? Yeah. So would we subtract 180 and 65? Right, this time we would add. We take 180 and add, which is 245 degrees. And lastly, BDA. BDA, yes. That's it. Questions on any of this here? Okay. We ready for the angle addition postulate? Yes? Okay. Be ready for this. So arc addition postulate. So if 2 adjacent arcs, AB and BC, are right next to each other, and we know the measure of AB, and we know the measure of arc BC, we can add them together to get the measure of arc ABC. Yeah, and if I know the whole ABC, and I know one of the 2 parts, we can find the other. That's it. Yeah. So GE, so G E, and whenever we have two letters, we're always going the shorter distance from one to the other. So we'd have 40 plus 80, which is 120. G, E, F. So G going through E to F. So we can say 40 plus 80 plus 110. We can add those three together. Or we're really adding 110 to. Last one we have is GF. So 180 we don't quite have because we didn't have any of them be the diameter. But do we know what this is? All of that is 230, and the whole thing is, so I could say 360 minus, which is, so I looked at the part, because all the other three added together would be 230, yes? And the last one, GF, wanted everything, or that one section, that the rest weren't. So we took the other three away from 360 and found that GF is 130. Questions on this here? A recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measures. So it's always going to be the, so let's say AC. So we're going from here to here, yes? Since we're given two letters, we always go the shorter distance, or the shorter measure around. So between these two going this way or this way, well, we wouldn't go to the right of A because that's going to be a farther distance to get there. Because the only time it really doesn't matter which is if we're straight across through the center, diameter. So you're always going whichever way is not going to be half. So we're going to go this way here. Well, we have two. We have 29 and which is so AC is 137 degrees. Let's look at the next one. ACD. Well, we know what AC is, yes? AC is, and what are we adding to it? 7, 10, 2. So ACD is 220. The next one we have ADC. So A through D to C. So we can add 83, 61, and 79. If I was adding these together, I would do 9 and 1 first, because 9 and 1 makes a nice number. It is 10, which just leaves us with 3. Then we can add these together. They don't really add in a nice way. 8 and 1 is 9. 6 would make 15, and then we'd have 22. We have 223 degrees. EBD. Yeah. E BD 360 minus 61 9 7 9. Yeah, because 9 would give us 70 9 61. Yep. Well, okay, I'll show you that here, because think about adding, what adds to 61 to give us 360? So if we start with the ones digit, if I add 1 and 9 together, we get a 10, yes? So here I'm doing 1 plus 9, so we get 0. Well, this is now 7, yes? What do I add to 7 to get to 6? 9, because it would give us a 6, which would carry a 1. And what do we add to 1 to get to 3? 2. Well, this here is just counting up to get to our number. So if you do concessions or kind of count change back, counting the change back up to the next whole number. Or you can just stick this in a calculator and get 299. Questions on this here? We good with this here? Now, before we move on, let me get this color. Would A, 137 degrees be major, minor, semicircle? 220. 223. Yep. Minor's under 180. Major's over between 180 and 360. And 180 is semicircle. Do we need to see another example of one of these? We can do these three and then we'll move on because I don't think we need to dwell on this too long. I think we're getting the hang of this, yes? So if we look at this here, TQ is 120 degrees because we're just going from T to Q. Now, will this be a major arc, minor arc, or semicircle? Minor. Next one, QRT. So QRT. Well, that's everything except for 120. Exactly. So 360 minus 120 is. Will this be this would be a major arc, yes? Major arc because it's greater than 180. It is not minor. TQR would indeed be, so it is a, yeah. Yeah. Identify the given arcs as major, minor, or semicircle. Yeah. Any questions on these here? I think we feel comfortable with these, yes? Congruent circles theorem. We ready for this? Two circles are congruent if and only if they have the same radius. I mean, if two circles have the same radius, they have to be the same. Yeah. If, so in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Well, the central angle is the same as the measure of the arc. So if the central angles are the same, the arcs have to be the same. That's it. So, congruent central angles theorem. So tell whether the red arcs are congruent and explain why or why not. Yes. the central angles are the same. Yeah, a central angle is an angle whose vertex is on the center of the circle and whose sides are both radii. Or just an angle whose vertex is on the center of the circle. Four radii that are drawn. Questions on this here? So yes, they would both be 90 degrees, but they're not congruent. They're similar. Any circles that are not congruent are actually similar. Yeah. Because as long as it's a circle, if it's not the same circle, it's either bigger or smaller than in the other. So we can say they have the same central angle, and the circles are congruent. Because the circles are congruent and the central angles are the same, the two arcs are congruent. No. No, they're similar. Or we can say right, because the circles aren't. Well, the issue with it, well, because for it to be congruent, it has to have the same size and same shape.
So it does have to be the exact same.
So we can't say those two circles are the same because they don't have the same radii, so they're not congruent. Because one is technically bigger than the other. Now, technically, the degree measure of these two arcs is the same, but their actual length is different. Explain why or why not. Well, PS is the diameter, yes? So it adds up to be 180. So I can add 65 and yes, the yes, the central angles are yes, central angles are congruent. Questions on any of this here? Okay, we ready for this here? I've actually already said this. Similar. Because as I said earlier, all circles, they're either going to be bigger or smaller than each other, unless unless they're congruent.
They're all
So no matter what the circle is, it's either going to be a bigger version or a smaller version of said circle.
they all have the same exact measurement.
Yeah. Degrees wise, yes, and then just we're either making it bigger or smaller.